just coming through. Okay, right. We get started, folks. Hope you're all doing well. Stephen's talk is on 2026 total solar eclipse. In particular, focused this year, but I have some slides at the end on 2027 as well. It's very much like a pair of eclipses to think of it as. They're both happening in the late summer. Once these two eclipses are over, that is it for eclipses in Europe for another generation, 25, 27 years of that order. So these two are, it's been a while since we had an eclipse in Europe. We've had a number of them in the US and so on now for a number of years, but we have this pair. So I would really say pay attention to these two eclipses, because otherwise you'll be going to Australia or further afield to get the next ones after that. Okay. And you might just check the chat. Is everything?
I am, yeah. I am.
Okay, that's
keep an eye on things here. Yeah.
Okay. One moment. This is not going forward. Okay. So eclipse. What is an eclipse? An eclipse is when the moon passes between the Earth and the Sun, and you have. Go back up one. The sun is 400 times approximately the size of the moon, but it's also about 400 times further away. So as it would due to the moon is essentially like the perfect shadow, just by pure coincidence of nature. The size of the moon, the apparent size of the moon is almost exactly the same as the apparent size of the sun, and that's what causes them to perfectly block one another, leaving a small path along the Earth in which you're in the total eclipse path. If you're in the outer area, and that area is called the umbra, if you're in the outer part of that, it's the penumbra. In that region, you will only see a partial and no more than a partial. So that penumbra is a very small strip. That's why going to see these eclipses is quite challenging. It usually involves going on a cruise or a long haul flight in some shape or form, because it's pretty random where in the Earth these things hit. So that's what we're saying there about the 400 times relationship. The moon, interestingly enough, is moving away from us at about 3.8 centimeters per year. And we know that from the Apollo missions with the reflectors that were placed on the surface of the moon, with lasers fired on them quite regularly, we know it's moving away. And it's moving away from us due to the loss of energy caused by the tidal forces on Earth. That loss of energy means that the moon is essentially slowing down and is moving further away in its orbit. So a point will come when we eventually won't see any more eclipses. So we have this extraordinary coincidence of nature and time and to be alive and to be aware of all these things as humans, that we can actually observe a solar eclipse, be aware of what we are seeing, be knowledgeable enough as a species to understand what it is, and yet for it to be, and have that perfect relationship of geometry, and yet for it still to be able to occur, because future generations won't be able to see it. So I have a comment. I don't want to talk too much about the last one. Okay, there may not be eclipses maybe every single month. It's about once every 18 months. Typically, you can get more of them in July, August time, in December, January. Maybe slightly more frequent than other parts of the year. In terms of key items, so you need 3 items lined up. It's the sun, the moon, and the Earth. You need to have the right date and time. No point in walking up to an eclipse in Spain or Australia or whatever it is, the day before or the day after, especially the day after, you're definitely too late. Positioning of the observer obviously is critical, and the shadow path. You need to really understand that umbra is typically 1 to 200 kilometers wide, and you need to be in that to see it. And the position in that as well will also, where you are in the shadow will determine how long an eclipse you will see. And as I said, the penumbra is partial only. So the significance of this, so historically in 2137, there's the Chinese legend of the royal astronomers who failed to predict an eclipse, and because they were alleged to have been drunk. The emperor could not perform the necessary rituals to save the sun from being eaten or whatever the belief was, and so the 2 astronomers were beheaded. So that was a bad day at the office. At 123 BC, the Ugarit eclipse, one of the earliest recorded eclipses, documented on a Mesopotamian clay tablet found in modern-day Syria. At 763 BC, the Assyrian eclipse. This eclipse was recorded in the same passage as an insurrection in the city of Ashur, linking celestial events to civil unrest in early historical records. And then, I suppose, the famous one a lot of people know of is 585 BC, the Battle of Helios, between the Lydians and the Medes. They're interpreting the sudden darkness as a sign from the gods to stop fighting. Both sides agreed to a peace treaty ending a 6-year war. And you have to think back in these days, like science knowledge was nowhere near as it was. There was no internet, there was no AI, there was no 5G, there was nothing. And the knowledge of science was far more limited than it is today. We take for granted nowadays. So when they were looking up, this was the sky, what the heavens, that was their television. And they were literally seeing the sun disappear, which must have been quite a shocking thing for them to see, especially if it was not planned or not predicted, we'll say, and they were not aware of what was happening. From a religious and political significance, 29 to 33 AD, the Christian Gospels mention the darkness that fell over the land during the crucifixion of Jesus. At 632 AD, a solar eclipse coincided with the death of the Prophet Muhammad's son Ibrahim. Rather than claiming it as a personal omen, the Prophet Muhammad used the event to teach that eclipses are natural signs of God and are not tied to the life or death of any individual. Very often before that, they were seen, it's a bit like comets, they're often seen as a negative thing. They're most of the time they happened unpredicted, and that brought a sense of fear, and in particular that was seen as a very negative thing. But in this case, the Prophet Muhammad took a different perspective on it. At 1133 AD, the death of King Henry I of England coincided with a total solar eclipse, reinforcing the superstition that eclipses portended the death of rulers and led to a chaotic struggle for the throne. In 1831 AD, Nat Turner's rebellion, the solar eclipse was interpreted as a black angel occulting a white one, and that was seen as a divine signal to launch a slave revolt in Virginia, USA. So from a scientific perspective then, in much more modern era now, 1836, that was when Francis Baily first described the beads of light, what we call now the Baily's beads. This is the last glimmer of sunlight shining, just skirting the edge of the moon, through the valleys along the edge of the moon's surface, just before and just after totality. In 1851, Johann Julius Friedrich Borowski took the first successful image of a total solar eclipse, capturing the solar corona for the first time. And the solar corona, that's the star performer really of a solar eclipse. And I'll be going through all the various aspects of what to look for in a total solar eclipse. In 1868, the French astronomer Pierre Janssen observed a bright yellow line in the sun's spectrum that did not match any known element on Earth. This led to the discovery of helium, named after the Greek sun god Helios. And in 1919, you have the Sir Arthur Eddington's team to photograph stars near the sun. First observational proof for Albert Einstein's general theory of relativity. And there's a little Irish connection there for those of you who've been out in Dunsink. Some of the equipment that was used on that trip is on exhibit out in Dunsink Observatory, if you remember seeing that. So in terms of safety, obviously you can't mention anything about the sun without talking about safety. Safety is your responsibility, not the club's or mine or anyone else's. Do your research, buy from sensible, well-proven providers, do your homework. Obviously, we all want to see an eclipse, but we only have two eyes. Most of us are fortunate to have two eyes, and it's very difficult to replace them, obviously. And they're easily damaged. So mind yourself, get the proper solar eclipse shades if you're observing. If you're using anything like a telescope or binoculars or anything like that, make sure you put caps on with the solar filters. But obviously, there's one key time you do take them off, and that is for totality itself. When totality happens, that is when once you're deep within the shadow of the umbra, that you're not just somewhere in the partial phase. Once you're in the umbra, you can take any filters off and observe the glory that is the solar eclipse itself. Because it'll get so dark anyway. I mean, you won't see anything. You definitely won't see anything if you still have glasses on. I can tell you, it'd be very safe. So in terms of eclipse chasing, my first one was in 2006 in Turkey. Then got addicted after that. Then we decided to head off to Novosibirsk, Siberia in 2008. We got really lucky with the weather. 2009, unfortunately, in China was a washout. And then on 2015, we went on a organized trip on a private aircraft chartered flight over the Faroe Islands. Got to see it at, I think it was about 40,000 feet. Then in 2017, we went to the US, to Wyoming, and there was fantastic clear skies there. And then went to 2023 in Utah at Monument Valley, just outside, literally across the road from Monument Valley. It's an annular eclipse. Monument Valley itself was closed for the eclipse in respect of the beliefs of the Native Americans, because when an eclipse occurs, they actually stay indoors. They see it as a moment of intimacy between the sun and the moon, and they should not be looking at it. And so all their facilities were closed for the eclipse day. So just to give a sense of cultural perspective to all of this. And then in 2024 in Arkansas, was fortunate to see it there, as after a chaotic driving from Dallas up into Arkansas to try and chase these crazy, who are these crazy eclipse chasers, you might be asking. So hopefully once I take you through this journey of what to see, hopefully you too will become an eclipse chaser. Maybe I'm sure there's definitely a few eclipse chasers in the room, and hopefully give you a flavor, a little taste as to what you might see. And but nothing I'm going to show you, or no, and I have a video and sound and all the pictures and all of that, nothing I can say is really going to give you the full experience of what a solar eclipse is. So you have to experience it. I have to be there. There's no words or video or sounds, or you could listen to 1,000 PowerPoint presentations. It still will not communicate what is a total solar eclipse. But I've broken into two halves here. On the left-hand side, I have what I call the light show, for want of a better phrase. It takes you through the start, the partial phases, the shadows, what to see in the night sky as the sky is getting very dark, shadow bands and so on. I'll go through all of those, right down to diamond ring, Baily's beads, prominences and corona. But then there's the other aspects of it. The cultural side, the travel, the people, the experience you're going to go through, atmospheric conditions, wind and temperature, and sound. So on the cultural side, to kind of primarily cover on this, on the right-hand side I'll cover on this slide, it generally involves traveling to another country, and you're meeting, this is a one-off trip for most people. Most of the time you're heading off to somewhere long haul from Ireland, and it's a big trip. Obviously travel is a fantastic thing for opening up the mind and experiencing new things and food and culture and people. And you're able to meet you will meet all these eclipse chasers as well along the way. And you're able to share that amazing experience with people, especially with those who have never seen an eclipse before. There's that one moment of wonder and awe when you go through a total solar eclipse. From an atmosphere perspective, as the eclipse is happening, it will get quite dark, and the wind normally calms down, and the temperature can drop significantly. So most of the time you're heading off to some warm country, and you're sweating and it's warm, and then suddenly it's almost like nightfall is coming, and you will feel the chill. You need to put on a sweater or a jacket, because temperature may drop by in the order of about 10-12 degrees. So as your skin is perspiring, that will have a cooling effect on the skin. So again, it's all a part of this experiential nature of an eclipse. It is not just a video, like watching a TV show or anything. You will feel the eclipse as well, and that's one of the important things to emphasize. And then the sounds. So the birds think it's evening time. They will go back to their nests. The whole place quietens down. It becomes quite a surreal environment and experience when you combine the temperature, the wind, the birds, and then along with the light show. It's a total, I know we say it's a total solar eclipse. It is a total solar experience. So we'll start off then on the light show element. So first of all, you have the partial phases. So this takes, if I recall, in the order of about an hour or so. And this is where the moon is gradually creeping across, from our perspective, is gradually creeping across the disk of the sun. And you will see it building gradually. Obviously, during these phases, you need, the sun is exposed. You will need all your solar filters on. The safety is number one. And if there's any sunspots like there was here, you'll see the moon kind of gobbling them up as it's nudging along, eating all these sunspots away. And then the tension is building, the suspense, the excitement, the adrenaline is building through this phase. There is a particular culprit. You can see there, suspicious character. I think we all know. The great Mr. Flannery himself, and he is, and I have this under the banner of shadows. And what John is doing here is using a little colander spoon, and he's casting a little shadow onto the seat there. And this other slide shows it in a bit more detail. And this was in Turkey as well, those two photos. And this is the sundog, I think we called him Canis Major. And you can see all these shapes of the sun. So we take for granted shadows in normal light. The sun doesn't change every day, so we see light and we see a shadow. Might be under a tree, for example. We just see a light pattern of leaves underneath a tree. But during a total solar eclipse, every shadow becomes almost like a pinhole camera, and it'll represent the shape of the sun. So with the light shining through the circular holes on the colander spoon that John was holding, each one of them will end up, even though there's no magnifying glass or optics or anything, each one of them will represent the shape of the sun at that time during the partial phase. And the same will happen underneath a tree. Underneath a tree is actually quite spectacular. You'll see thousands of little crescent-shaped suns all underneath the tree as it's shining through tiny little gaps and pinholes in all of the leaves. In terms of planets, so the sky, as I said, is getting darker. This is a photograph from something on my screen. Not sure if I can move it. Bear with me 1 second. It's not coming in at your end. Right. So this is from Siberia 2008. All these photographs are my own, unless I state otherwise. And this is the moon here, just kind of a slightly long exposure. And then that was the planet Mercury at the time. So you'll be able to see the likes of Mercury and the major planets during a total solar eclipse on the build up to it, a few minutes before and a few minutes after. And you can go to the likes of stellarium.com. I'm sure most of you are familiar with this. You fast track to a particular moment in time, put in your location, and they'll show you what's visible in the night sky. At the time of the Siberia eclipse, Mercury, Venus, Saturn, and Mars were all visible in a nice, lovely straight line there, more or less, during totality. And it's worth planning out this in advance before you go, so that when the total solar eclipse happens, you'll recognize what objects are visible, these star-like objects in the night sky. In terms of stars, so some of the brighter stars are also visible. So this is from Wyoming in 2017, and this star here is Regulus in Leo. And that was quite noticeable to the unaided eye. So again, it's interesting, just some of the brighter stars are visible. This one here, this is an old sketch. It's from the book here I mentioned at the bottom. And this is something that's very difficult to photograph for reasons I'll go into in a minute. But this is shadow bands. And shadow bands are patterns of light that appear to wiggle and move across the ground, which a sense of motion, a very obvious motion. I've only seen them once or I think twice. Not obvious to see because you kind of have to be looking down. And when I saw them, it was literally in the last few seconds before or after totality. And what it is suspected to be is that when the moon is covering the sun, you're left with a tiny pinpoint of light, almost like a laser, essentially. Think of it like a tiny source of light as opposed to a diffuse light when the sun is at its normal phase. And as it's shining down through the layers, even though the sky is clear or appears to be clear, it's kind of being wiggled and moved along by air currents in the atmosphere. And what you're seeing is almost like a polarizing effect of, as the light is bending through the atmosphere in tiny bits of haze, it's causing this little kind of moving pattern, the speed of which is matching the motion of the air currents in the upper and lower atmosphere. Very difficult to photograph. Most cameras are, it's so subtle. Yes, you can see it to the unaided eye. It helps to put down, you'll often see if you go on these eclipse trips, people will bring a kind of a white bed sheet or something like that with them on a white background. It helps to improve the contrast as to these shadow bands moving across. Hard to take in everything. There's so many things to see. I'm going to dump all this stuff that you could see, and chances are if you go, you might see a quarter or half of them. Okay. But it's to give you a flavor as to all the things that do happen during a solar eclipse. This is the one that we saw from the aircraft over the Faroe Islands. And it is just an example of a photograph. I've tried to pick different eclipses to represent different effects. And this I call the 360-degree sunset. So you're familiar with a sunrise and a sunset. When the sunrise or either or, it's a red band that will generally occur over the region of the atmosphere, over the horizon, where the sun is just disappeared behind. But the sun has not disappeared behind the horizon. The sun has disappeared behind the moon. So, but that still creates a 360-degree sunset effect, and you get this beautiful salmon color effect of light, more pronounced than I think this photograph even reveals, and that goes around almost perfectly illuminated, similar level of brightness and color and height above the horizon, 360 degrees. It's like the perfect sunset. If you didn't know what was happening, you wouldn't really know where the sun had set. It's just like as if it's set everywhere. And what's also interesting, I'm not sure if it comes up on another slide or not, no, maybe not, is that this side of the sky is darker than here. Here we're still just in the last throes of partial phase, and over here this is the totality moving, because of course the moon is moving, and so it's the shadow is moving. So a lot of things are moving, like the Earth is moving around the sun, the moon is moving around the Earth, and the Earth is rotating. So there's very complex geometry that is, I'll go through a little animation of it in a couple of minutes as to the path, for example, for 2026. But I distinctly remember to this day, very strong memory of when we were in Turkey on the first eclipse, and we were at Manavgat overlooking the Mediterranean, and we could see the shadow band coming towards us, and it was like this great big thunderstorm was coming towards us, except there was no cloud. It was clear, perfectly clear sky, but yes, this depth blackness, which you could see rushing towards us, coming across the water. So then now we're into the very, very last couple of seconds of partial phase, and this is what's called the diamond ring, the famous diamond ring. And it's called the diamond ring because this is the last little burst of light, probably shining through a little valley on the edge of the moon. And then you have, so that's your diamond, and then you have this ring of light all around it, representing the ring itself, hence the name diamond ring. Quite a spectacular sight, and it's easier, I find, to get at the end of the eclipse than at the start of the eclipse. That's me personally, because on the build up to the eclipse, you have the solar shades on, you're trying to be safe. This diamond ring might only last for, I'd say, maybe a handful of seconds. And so obviously you have to get the timing of getting the glasses off. If you take them off too early, you don't want to damage your eyesight. If you take them off too late, you might miss the first diamond ring. But the second diamond ring will happen just at the end of the eclipse as well. So there's two diamond rings, one at the very start and one at the very end of totality, because the moon is moving. And that's it, actually. That's the reappearance. So that's what I was referring to there. The other thing you'll notice here, this is the same eclipse, the motion of the moon. You'll see the prominences up here, for example, on this on the upper side here on the 12 o'clock, 2 o'clock, and just after 3. And by the time it's come, the moon has moved so much, those prominences are covered. And these prominences now down here are particularly much more prominent than they were before. Oh yeah, so then, this is a few little slides then, if it will move. So this is only over the course of a few seconds. You can see the scale and the speed at which the sun is moving as the diamond ring builds up. And at this stage then, once you're hitting that sort of scale, you'd want to be putting the shades on. And that was from Arkansas in 2024. And oh yeah, and this then is the other effect of, this is like the very end of a diamond ring, where it really is shining through the last couple of bits of valleys here. And if you have good eyesight there, you might see kind of a roughness on the edge of the disc here. And that represents the little peaks and mountains and valleys along the edge of the moon. And these little bursts of light, almost like mini diamonds in themselves. And that's what they call Bailey's beads, after Francis Bailey. Prominences, which I mentioned a minute ago, this is one from Arkansas 2024. Very obvious prominences visible here, and they were visible to the unaided eye without any magnification or anything needed. And they were like, the camera doesn't even do justice to how red these things are. These are blood red, extremely red. They're pure red because of the wavelength they are in. There's no other shade than red in them. They're at 656 nanometer, and extremely red. So then we're into the kind of aside from prominences, we're into the main event here now. This is the corona. The corona, think of it as the outer atmosphere of the sun. It's about 1 million degrees Celsius, extremely hot, and it is it's gone for many years unexplained as to why it is so hot. So it's actually hotter than the surface of the sun itself. It's thought to do with the flow of electrons and so on, charged particles coming out from the sun itself. And in this case, you can see every corona as well. Like this corona is from Wyoming in 2017. Every corona takes on a different shape. It's all down to the activity of the sun at the time, on the day. There are certain patterns, like this corona was taken during a time around solar minimum. And so there are, you have these three prominent streamers that go quite far away from the sun. Whereas, do I have it on the next one? Oh, no, I don't. I think I might have it on another slide later. But then you have other eclipses where the corona might be much more complex. You might have 7 or 8 or 9, so on, maybe much more complex structure around here. But it might not extend quite as far. And that's to do with all the storms, the magnetic storms and activities that are taking place on the sun at the time. I mentioned earlier about photographs. I just touched on that, and about shadow bands and how they're hard to capture. Taking eclipse photographs is extremely challenging because our eye is an extraordinary camera in itself. And it has a dynamic range. What I mean by that, being able to see from black to white in kind of the equivalent of like a single exposure, far greater than the vast majority of cameras. So we are in here in this room, and you're sitting down. It's quite a dark room. And yet you're all able to look up at the screen. You can see the range from black to white quite easily, whereas a camera really struggles to do that. So the dynamic range of the human eye is at the top band here. You can all see from the blackest black to the whitest white. But a camera can't really do that. A camera is limited to kind of certain range of what's called stops. It can only see a bit in the middle or so. So if you were to represent that more, what a camera would see, once you get below a certain level of darkness, it's just black. Just if I was to take a camera now in the room and take a photograph here, if I was to get it focused, say light-wise perfectly for this side of the room, this side here, and the other half will be completely black, in shadow, not visible. Yet I know I could see it. So that's what makes taking photographs extremely challenging. So the way around that is to take a series of photographs of different exposures. So in this case, if we took a middle of the road exposure, we would capture the middle range of what the human eye would see. If we took longer exposures to get in more light, we would then see the darkest steps of what the human eye would see. Or if we took short exposures to chop down the amount of light it was coming in to make sure it's not saturated, we could get into brighter regions. And that's what they call HDR, high dynamic range. This is where you take a series of photographs and try and merge them together, do their exposures, so that you're able to capture or some way reflect what the human eye itself would see. So when you see most photographs of a solar eclipse, they generally have a black sky background. That's because they're generally one exposure. And to capture anything around the corona of the sun, tight in this case, that's one that's really tight in, capturing the prominences. But that's not what the human eye sees, because the sky isn't yet, I mean, it's dark. Maybe it's a dark blue or navy color, you might say, but it's not black. So the trick is to take a series of exposures, starting from about maybe 1,000th of a second and building it up to maybe 12, 13 photographs, up to about a 2-second exposure, and then using certain techniques in Photoshop to be able to blend them together. So this is a series of images from the Arkansas, the eclipse we saw in Arkansas 2024. And I'm just going to scroll through a series of images here. So when we were in here, we could see the very inner region of the corona and primarily the prominences. As we extend out, we're starting to capture some of the middle regions now of the corona. You can see some of the structure in the corona here. These various rays that are coming out all over the perimeter of the corona. But now you can see the inner region is completely washed out, completely saturated. But the human eye can still see them, but the camera is more limited. So as we keep going, now you're into the more outer regions of the corona. You can now see the sky background itself is no longer jet black. It takes on a kind of a grey blue. And if we keep going, we can actually even get to the point where we're capturing earthshine. Now, earthshine, for, is, you'll all be, for most people I think would be familiar with, is typically in a small crescent phase of the moon. And that's where the light from the sun is bouncing off of the Earth's atmosphere and then back up to the moon and back down again. So you might be wondering, how do we see earthshine during a solar, or how can the camera capture earthshine during a total solar eclipse? And that's because the moon is just blocking the sun from where you are. But the rest of the earth is still quite lit on that side. 99 point something percent of it can still see the sun. And so that light is bouncing off the earth's atmosphere back up onto the near side face of the moon and then back down towards the person in the shadow. Now, I've never seen the earth shine effect because this is a long exposure. This is about 2 seconds. So this is a longer exposure, kind of equivalent to what the human eye can see. But now we've essentially taken images here from the shortest of the short to the longest of the long, for want of a better way of putting it, to try and, capture a dynamic range that's even beyond what the human eye could capture. And then we can blend them into Photoshop using a high dynamic range to come up with a corona that's much more realistic to what the human eye can see. So now you don't see a black background here. You see there's a lightness, or kind of a dark navy, would say, to it. Colors come in a little different than my monitor. But and there's even a couple of, so there's 2 stars there, little double star. They're about magnitude 7, believe it or not. You won't see them, or at least I wouldn't be able to see the stars that came during the solar eclipse, but the camera was able to pick them up. And then you see the complex nature of the corona itself. And really, it's only during the solar eclipse or one of the more dedicated space satellites that use occultation disks that this can be captured. It's just not possible, even from the most sophisticated of equipment, really using coronagraphs and so on, to get this level of detail this tight into the solar surface is extremely challenging because of the nature of the sun itself and how harmful it is to equipment and human eyesight and so on. So we're still able to capture a couple of prominences, and yet we're able to get all the complex nature of that corona. And that's just, you can put a photo up, but it actually just to see it, to experience that's what's just totally incredible about an eclipse. And then you can go one step further. So this is, some people like this, some people hate this. It depends on your taste. This is where if you stretch it even more and you bring in the earthshine. Now, this is beyond what the human eye can see. This is kind of more showing off what Photoshop can do. And just, if you really push the boundaries of photography, everything you see here is real and is there and photographed at that place, but it's just stretching beyond what the human eye can see. This is from 2027. And now you can see the contrast between this eclipse and the corona during solar minimum. And you can see the 3 long streamers. Some people were saying it's a bit like the Star Trek symbol, communicator badge, versus the whole complex nature here of the corona during 2024 but literally right at solar maximum peak. So it is, and again, every eclipse will just have a different corona. And there are some prediction models that might be released maybe a week or 2 in advance as to what it might look like, but nothing super accurate. You really have to rock up in the day and see what it looks like. Oh yeah, I'll play a video in a second. So that's photographs, but it's only light. It's a 2-dimensional effect, and it's only capturing the light show as I referred to earlier. Now, bear with me a second. So I captured I go into here. Right. Hopefully the sound will come through. For those online, let me know if it doesn't come through. The sound is particularly important here, so hopefully it plays. So what I captured here is a series of, I was trying to figure out the last time on my last eclipse, what can I capture a bit different than just photographs? So I just put on the voice memo function on my iPhone with very little expectation. I had 0 practice. I only thought of it about 5 minutes to go before totality. So I stuck that on and then I superimposed the sound with some photographs during the eclipse. They don't perfectly sync, but hopefully it just gives you a flavor as to from the sounds, just a little bit more about what the experience is like. This will take a few minutes.
There was clear at 10 o'clock. Well, okay, start looking up.
Can you hear that? It's only coming through here.
Yeah, people will probably even hear it better. Okay. I turn this.
Have we a way of getting
there is the volume up. I never know which then on that.
Okay. I might need to mute my volume here. So.
Careful of the combinations.
Okay, start looking up, folks.
Oh, wow.
Diamond ring.
No. Okay, mute that one. We'll just have to work with this speaker.
Yeah, and they'll actually hear it maybe even a little bit clearer online because they're right beside your mic.
Ring.
Oh,
There you go, diamond ring. Wow.
oh, God.
Hey.
They can hear it.
Wow. Wow. Lots of streamers. 11 o'clock. 7, 6, 4, 2 o'clock. Venus is really clear. Jupiter is clear. I thought I saw Saturn down there as well, faint on the lower right, the 4 o'clock position.
Oh, look at the sunset. Look at that. Oh, Mike.
So the sunset was front to earlier.
Now look at the sunset. Look at the even red glow all around. How calm it is. It's not supposed to be cooler.
4 minutes was it something that were particularly long. Sounds very short. For an eclipse, it's long.
Oh, look.
That's just me, Jim.
Oh, wow.
So you might hear the clicking. That's everyone without their cameras clicking.
No flashes.
Oh.
No flashes.
And you'll see it shifting a couple of times in a second. So I didn't have a full 4 minutes of movie, so it's just a series of stills.
That's a couple of nice prominences.
Yeah, so that one adjusted
12
now.
o'clock, 2 o'clock, and particularly at 6 o'clock.
12, 2, and 6 o'clock.
No?
There's one at 6, yeah.
The naked eye?
Oh, I'm looking at binoculars.
Yeah, there's something, I can see something like a little red. I don't know.
Yeah,
The 6 o'clock one will just become a permanent distance.
Was it hot in Arkansas?
Warm, not too hot. It's just, yeah, it's okay. It's mid-20s, I'd say.
Yeah, very hot in Lakeville, I saw it.
Okay, yes, that one is what
So see prominence at 6 o'clock.
6 o'clock. Yeah,
Quite
that's the
easy
thing.
now.
It's like a line coming down.
Yeah.
Yeah, that's cool.
That's my wife Denise is with me.
That's one.
She's
Wow,
more of an eclipse. Than
That's
Best prominence I've seen. Yeah. You can see that big line.
And the train in the background, so that was
Very clear.
yeah.
Train in the.
Wow.
I don't know.
Saturn is faint. They're quite faint down there on the lower.
Where's that?
And there's a star next to it, if I'm seeing it correctly. Yeah, quite close
I'm
to it.
calling out the for those who can't back. I'm calling out the various stars and planets that were visible as well.
It is cool. I haven't seen a prominence that. Look at that, sticking out of all.
You can see it. The naked eye, like it's. Oh, okay.
Now, when are you ever going to see a naked eye prominence again?
Wow.
Keep an eye on every
Now, what you see, the sky is bright on the right hand side.
Yes.
Then on the left hand side. So the shadow was going, and we're coming near the end of totality now. The sky brighter on the right. Wow, noticeably long as well. 4 minutes something. Yeah, fantastic.
That was a good long eclipse.
That's long. You can get the 6 minutes, I think.
Yeah.
That's
Yes. Spain is only going to be between 2.5 minutes.
Yeah.
It's big.
It is, isn't it? It's huge. Now, diamond ring.
Oh wow! Oh, that's great. Look at that! Wow! Wow!
Oh, I got
Wow.
I got
Whoa! Wow!
You start running out of words.
Дайте веселий,
Oh.
показує, що скоро
Oh, yeah.
You start running out of words when you're in the moment, you know, and it's hard to, what's the point? Okay. So 2026, hopefully you're all psyched up now. You really want to go on this thing, these crazy eclipse chasers. So it's Wednesday, 12th of August, mid-August. Just a little animation here. This is what I referred to earlier about the Earth's rotation and obviously the moon is moving. So that little black dot, that is the size of the moon's shadow, the umbra that I mentioned earlier. You have to be within that path to see totality. The outer kind of circle you see, that is the penumbra, partial phase only. You will not see totality. It's literally a night and day difference. A 99% totality, partial, you know, it's not total. It's literally a night and day difference between 99% or 100%. So they did some research after the couple of American eclipses, and what they found was that there was a misunderstanding with some members of the public in that they thought if they were in the southern states, we'll say, of the US, and they were driving up north into the eclipse path, and they thought that, well, if once they got so many close, it would be good enough. Okay. But now millions did travel, right? And at the time when we were in Arkansas, we left the Fort Collins in Colorado at about 5 a.m. and we were heading north into the eclipse path. And it's like what you'd see on CNN or Fox News or whatever. It was like hurricane evacuation. It was bumper to bumper. Everyone doing 60 miles per hour northbound on the motorway. And then but once every 10 minutes, there was one car coming towards us on the opposite side of the road. Otherwise, it was just, and like literally millions of people. It was the highest number of vehicles that crossed from Colorado to Wyoming in their entire history for a one-day border transfer crossing, essentially. And it was fine getting in. We were going good in early. We had backup plans as to places to go. We were intended to go to a couple of national parks. They were fully booked out at whatever, 5:30, 6 o'clock when we arrived. They were full. And we parked up on the grass at a kind of a, not even a truck stop type place, basically on this, you know, there wasn't even a shop or just a toilet stop, basically, along with several other 100 people off the side of the motorway to try and see the eclipse. So for 2026, this is kind of a fractional cloud map. The two red bands here represents the path of the umbra, totality. And then you can see here for Dublin, we're going to experience about 94%. Down at the very southern tips of Cork and Kerry, you'll get to about 97, 98% or so, something like that. But as I said, it's not 100%. And there is significant difference between the two. The color here represents the color, the average predicted depth of or fractional amount of cloud that's likely to occur for that day per year based on a statistical analysis looking backward in time. It's not a weather forecast as to what will happen. But you know, statistically, obviously the statistics usually add up. Doesn't always work out at that time. We went to China. That place in China was considered about a 50-50 chance. And yet there's people who went to northern India where it was predicted to be 90% cloud and they got to see the eclipse and we didn't. So it's just, but if you go to enough of them and you follow the statistics, it'll definitely work in your favor. So if you start at the top, so obviously we're heading further north here, up around Greenland. You can see here as it crosses through Greenland, you're in the very high, still you're at about maybe 50 to 60% chance of cloud on the mainland of Greenland. But once you go into the sea, then you're up at about 80 to 90%. As you head further south, it's going to cross along the very western edge of Iceland. The red line represents the center of the path. The blue line is the edge. So it's only barely clipping the edge here, but it is passing through Reykjavik. So some people might say, I'd love a holiday in Iceland and fly into Reykjavik. And the little bonus might be the eclipse. That might be, you know, some people might have that take on it. In terms of cloud, unfortunately, it's not good. You're up at about 70 to 80% likelihood of cloud. And that's you know, for all of Iceland. But again, there's just that region. And as you, from a timing perspective, the most they will get is just over about 2 minutes. At Reykjavik, you're at about 40 to 50 seconds. So you really ideally would get in a car if if you're definitely intended in going to Iceland, you'd want to be going in your car from Reykjavik and heading as far west as you can. Then you're going across the Atlantic, and of course, some people might be in one of those cruises that are being organised over the ocean. It's not good. If I go back in time here, you can see you're about 90 something % likelihood chance of having cloud. But obviously, you're paying your money, you take your chance. The closer you get to Spain, the prospects improve. But then they improve massively when you're over mainland Spain itself. For those of you who may be familiar with Spain, you have the likes of Bilbao here and San Sebastian very nearby. And the Santiago de Compostela, some of you may be planning maybe this trip, getting a walk of the Camino as well. And then you head down. It just passes just north of Madrid. In fact, the edge of it is right along by the edge of the airport. The airport is to the north east of Madrid. And then it passes over the islands here, Ibiza and so on. So depending on what you're into, some people may be visiting here. However, there are some drawbacks. I suppose one of them, first of all, obviously you have to think of statistically in terms of the cloud. This shows indication as to where it's best to see it. You can see the red line here is the central line of the shadow, and the blue lines are the northern boundary and the southern boundary of the umbra. So you have to be within this. Some people will absolutely really want to be in the central line. To be honest with you, it's not critical. Once you're in about the middle 2/3 of the eclipse, just consider yourself lucky to see an eclipse. You're doing well. Don't be too obsessed about being over the central line. The timing difference is not actually massively different, and I'll show you that in a second. It's far better to get 5 seconds of a clear sky of totality than, trust me, than to have 6 minutes in a distant country under a thunderstorm and you can't see the bloody eclipse, right? So that is if there's a gap in the cloud, go for the gap in the cloud. It doesn't matter how short it is, that's the place to be. There's no point I won't say no point, but being underneath a cloudy sky is very frustrating during an eclipse. That's all. That's the nicest way to put it.
Because I think it'll be right there.
You're going to be about there, is it? Yes.
Brilliant.
So along that southern half is generally, or somewhere up around Zaragoza, are statistically the recommended areas. Myself,
to press people, we had a talk from one of our Spanish colleagues at Christmas, and he said that it was a quirk in the statistics, but on the exact same day in 2025, Spain at 95% cloud cover.
Oh yes, but it's right, and the other thing to watch here is that this is near sunset, so this is late in the day. So you have August, peak summer heat, and so there's a whole weather aspect of this. What might be clear at 12 or 1 or 2 o'clock may not be clear at 4 or 5 o'clock in the evening. Without I'll get the time here in a second. So cloud can build up to do with the heat during the day. So it's one of these eclipses you're really going to need to be on your app, having a look at like the likes of YR or satellite imagery or whatever to keep an eye on it. How is this? So the clouds won't necessarily be blowing in necessarily that far inland from the Atlantic, although they could. But they might be just convectional clouds that are building up from the heat, the water evaporation off the land during the day. So generally this half along here, and myself, we're flying into Madrid. We're going to spend a few days in Valencia, and then we'll be before the eclipse, and then we're going to head up probably in this region here. But we've hired a car, keep an eye on the weather, and just drive where we think there will be a gap, and just return back to our place at the airport that evening. Most are, there's been, I wouldn't say most, an awful lot of accommodation in this area is booked. My wife has been talking to people from Spain at her workplace, and they've all been puzzled as to, like one of the guys, he was trying to organise a wedding or some function here, and it happened to be around this time of the eclipse, and he was totally unaware of the eclipse. And he's ringing all these hotels, and all these hotels are booked out. And why are they booked out a year in advance? And he was puzzled. And he still couldn't get over as to where are all these people coming from, and are people really going to travel to see an eclipse? That's kind of the local insight, basically, as to these eclipses, from perspective of normal people as opposed to eclipse chasers. So the key thing will be my recommendation is stay mobile, get a car if you can. In terms of getting in here, Madrid is an obvious point. Then you have Bilbao. And in fact, in about this time last year, I got the ferry over to Bilbao from Ireland, from Rosslare. I was putting my telescope into a remote observatory up here, so I drove through and I used it as a bit of a a recce to see the northern Spain as well. You can see here along that northern coastline is more likely to be in cloud than in land. And that is to do with the direction of the wind. So the wind generally comes from the north, so it's blowing water and humid air in from the Bay of Biscay. And so there's quite a high range of mountains along here. So that is hitting the mountains, and obviously the air is rising, it's condensing, it's forming cloud. And in fact, if any of you are familiar with this area, there's a road around Leon that heads up towards the north coast, and it's going through a particular region of mountain. And on that motorway, I only stumbled across it by accident. You will see signs, all these warning signs coming up, and then they say nebula, which is Spanish for cloud. And then suddenly the speed limit drops on this motorway down to about 50 kilometers an hour. And then you see the cloud bank rushing in, coming in from the sea, and you're dropping down on top of the motorway, and you're in dense fog. I won't say it's permanent, but it's obviously there regularly to say they have warning signs and lights up and speed restrictions. And you have the fog lights on, you're crawling through this fog. You definitely cannot go more than 50 kilometers an hour. And you're driving along for a couple of kilometers, and then you're out of it again. So that is just a real visual representation of how the cloud is, hits the mountains, rolls up and condenses down, or how the moisture comes in from the sea. So that is an area of concern. Now, like anything, this is statistics. Statistics can change on the day. This area might be perfectly clear and maybe cloudy down here. The other quirk of Spain is that it's on average the second highest mountain in Europe. That might certainly surprise me when I heard of that. Switzerland is the highest. You have quite high plains along here in this region, and they tend to be drier, and they're more inland and they're more protected from the sea, from the moisture coming in. That's why these areas have better cloud prospects than the coastal areas. And then the last thing I will mention is the altitude. When the sun is at this point here, it's only about 10 degrees above the horizon. Whereas when it's down here, it's only 1.9. So it's going to look quite spectacular as an eclipse in its own right. And seeing an eclipse that low to the horizon is something I haven't seen before. We've all seen a full moon rising and the supermoon and all this hype and stuff. But when a moon is near the horizon, it does, to the human nature, and when we're comparing it to a distant tree or a house, it does appear bigger. So it'll be very interesting if we can actually, how will it look at the time during totality? How will it, some photographers I know are going over here and they want to capture it literally right on the water, just barely above the water surface. Obviously, when it is that low over the horizon, you need a very long run of clear sky. So having a little local patch of sky clear isn't going to be enough. It needs to be an entire region that is clear to be able to see through the Earth's atmosphere all that distance to see the sun at just 10 degrees above the horizon. So although the cloud prospects are saying you're probably in the maybe 20 to 30%, that's great in theory, but given that it's so low, I'd say it's probably about a 50-50 chance, to be honest. Okay, being realistic about this. But it's like anything, if you don't go, you definitely won't see it, So, and these are two eclipses. These are as close as they're going to be for a generation. The next one isn't until 2050 something. So I think it's Romania or somewhere Eastern Europe like that. So they're on our doorstep. Affordability, Ryanair flights are still readily available in here. Spain is one of the most touristy countries in Europe. It's like as if we're to design an eclipse, you'd be going for Spain, essentially, if you could, with the amount of accommodation. And you have fantastic sites and everything, culture and food and wine and everything here. Between Bilbao, all along the north coastline, San Sebastian, you have Valencia, Madrid, and so on here. So lots of places to see. So really packing in as a holiday, not just for an eclipse trip. And that is what the sky will look like according to Stellarium. Obviously, the horizon is just a generic horizon packed in. But what it does represent here is how low the moon is relative above the horizon. And you can see Jupiter and Mercury stuck behind a tree. When you remove those, and that line here represents the horizon, you can just see how low this is. But, if you are observing it, Mercury, Jupiter, and Venus are the ones to watch. And all three should be visible, I would say, quite easily. Venus, at that distance away from the moon, certainly will be blazing bright. That'll be very easy to see. Jupiter and Mercury, I would expect, will be visible as well. Once it's not too dusty in the atmosphere. Of course, again, this is late summer. You're in Spain, so it is more subject to dust coming in off the Sahara. But hopefully, look, fingers crossed, we'll all have a clear sky for that. And I mentioned there about time and about don't be too obsessed about being in the center line, the exact center of the path. This here kind of is a contour analysis essentially of the timing, the duration of the eclipse. So that contour, anywhere in that region here, you're about the 1 minute 40 of totality. So whether you're here or here, it's more or less the same duration. So it's all here now about cloud. That's the number one thing to watch here. You're not really going to gain a whole lot by being here versus here. If it's clear, and pretty much everyone will get the same duration. It's only when you get to the outer two-thirds, but of course you have to bear in mind, this is a circular shape. So it's all to do with the geometry of a circle. Then you can see the timings drop off rapidly to 0. But once you're anywhere between maybe somewhere around Segovia all the way over to about Victoria here, in that region there at all, if you're confident you'll get a clear sky, go for it. Don't be too worried about it. So that's just something to watch. Something, you don't need to be within a mile of the center line or anything like that. This is an extra little slide, actually. I knew there was from a solar eclipse conference I was at in Leuven last year. The Spanish scientists have been doing some shadow analysis of the eclipse, and particularly along the east coast, where due to the mountainous nature of the country, many areas will be in shadow. And so if people position themselves in the unfortunate enough to position themselves in the wrong place, it'll definitely be eclipsed. Unfortunately, eclipsed by a mountain as opposed to by a moon. So you just need exercise a bit of caution there. In particular, along the islands here, you'd actually really want to be on the beach. If some people, and it's up to each their own, they pay their money and maybe you have a holiday home or whatever here, get yourself literally on the beach. That's where you need to be to see it, because these islands are so mountainous, the vast majority of the island won't see it. Okay, so something to watch. So the further west you can go, ideally, the better. In terms of recommended reading, if we're into eclipses and that, Kate Russo has written a couple of books on this. Being in the Shadow, very much from the psychological nature of it, the human nature of it, aspects of it, what it's like. 2 books actually here. One is Being in the Shadow, stories of first-timers. So particularly good to see, just follow the journey of people going to see an eclipse for the first time. Then her other book is Total Addiction. And then the third one here I have is from the late Fred Aspanak. These books are still available. Yeah, that's right, unfortunately. Yeah, I know. Yeah, he died for short-lived, unfortunately, due to health issues. Guide to the total solar eclipse. You can pick these up off Amazon. Some good websites which I have referenced there are Jay Anderson. That's where I got all of the statistical weather maps, the climate maps. Fred Esback, who I mentioned a minute ago, he has eclipsewise.com, and then some very good maps that use Google Maps of eclipses. You can click in a place and it'll tell you the exact height and position of the sun and the duration and so on for any location. That's from Xavier Juvier, xjuvier.free.fr. So that's 2026. But I did say there was a pair of eclipses. So I want to give you a little sneak peek in 2027. For some of you who have suffered through this talk now at this stage, you've all seen, somebody has seen this talk at Galway earlier this year. I have some extra slides into the 2027 bit. 2027 is particularly good, almost the exact same time of year, also going through Spain, believe it or not. And this one is over 6 minutes long, okay? So this is the map of where it will be passing over the Earth's surface. This is the band through here. It's passing over the very southern tip of Spain and then over the likes of Morocco, Libya, Tunisia, Algeria, Libya, Egypt, and so on, down to Saudi Arabia and Yemen, and off into the Indian Ocean. Again, the red means high percentage of cloud. The blue is what you want to be going for, blue skies. Okay. This is a map here of the likes of southern Spain and northern Africa. As you can see here, very blue, which is exactly what you want to be seeing. You're down around the somewhere between the 0 to 15% probability of cloud. Okay, so it's very high chance of seeing this. This is one of the best eclipse maps I have seen for all the trips I've been on. Okay, so it's about as good as it's going to get, given how close it is.
That's long eclipse.
Over 6 minutes, yes, at peak place, which the peak is, I'll come to in a second. One of the comments I will make here about Algeria, Tunisia, and Libya, or maybe Morocco as well, certainly 3 of these countries, due to security issues these countries have had, unfortunately, in recent years, bringing in the likes of telescopes and binoculars can be quite restrictive. I know of people who have gone to Algeria in recent years and have had this equipment confiscated at the airport for security concerns, and it's been returned to them when they left. But even a pair of binoculars can be a problem. Okay, so bear that in mind when you're going to some of these places. Lovely places, absolutely, but unfortunately they have been fallen victim to terrorism, and the security forces there are quite cautious, we'll say. So just bear that in mind if you're thinking of, bringing lots of photography equipment. If you want to go there and obviously just visually observe it, that's no problem. And of course, you have a very good chance of seeing the eclipse. This is a cloud map. Sorry, I'll show here as well. The red line is kind of goes through Spain. That's the northern limit, right? That's the center line, and this is the southern limit. So for purposes of Spain, for the red line, from around Cadiz over to Malaga to Almeria, you've less than 20% chance of cloud. So it's very good prospects. Okay. But you'll see here once you get into the sea, the likelihood of cloud rises very sharp over the sea. You're up in the 50 to 60% range. So that is a disadvantage of going on a cruise, and that statistically you're much more likely to get cloud. Of course, a cruise ship is somewhat mobile, so we may be able to aim for a gap in the cloud, but that is something to watch depending on what you're planning for 2027. And then you can see it rushing down very low over here as it goes overland. Then some people will have seen all of the hype in online sources about it passing over Egypt, over Luxor, over the pyramids. I've heard for the last 10 or 15 years that all the hotels have already been booked up for Luxor. And the other thing I would bear in mind, this is August in Egypt, where the sun is at about 85 degrees altitude. Okay. It won't be cold, let's put it that way, right? So if you're sensitive to the heat, just bear that in mind. Do not be surprised if you're in around the pyramids and all the stone and the sand and the heat and everything, and if it's up around the 50 degrees, it wouldn't surprise me. So that is, some people love the heat. I wouldn't love it that much. Okay? So it's up to you, obviously. But if you're able for that, and you're an interest in history and Greek archaeology and culture and all of that, it will be a fantastic place. But obviously you need to be careful. It's a place that, unfortunately has been, known for scams now and then. And so you'd want to be very sure you have booked a place and you can go and see it safely, secure environment. And then you can see here, I don't think I've ever seen a map here. This is the cloud prospects over Egypt. It's down about 2 to 3% cloud. Okay. So it sounds fantastic, but this map I will show you. I think this is the last slide. This is the mean aerosol optical depth map. Basically, this represents the average map, giving an indication of the particulate matter, dust, essentially, that would be in the atmosphere. So while we've sometimes occasionally experienced a bit of dust coming in from the Sahara, this is the Sahara, okay? So you're going to have a lot of dust in the atmosphere. And now the sun is very high, it literally is directly overhead. So you'd hope it wouldn't be blocking it out completely. But there is a risk you can get the likes of sandstorms and whatnot. So while yes, the cloud prospects, there'll be no cloud, there is a risk of something other than cloud in the atmosphere. So something to bear in mind if you are planning. And obviously if you pick the likes of, you can see how clear Spain is in comparison. Over the sea, obviously, is very good as well, north of Libya. But then over mainland where the sand would be present, obviously there is a risk of potentially being some way blocked out. So you may not get completely blocked out, but it may potentially limit maybe the expanse of the corona if it's quite bad, or it might be harder to see some of the planets or background stars in the sky. It's just something to watch. Okay. So that is it. Thank you very much.